Now we're going to talk about the product of vectors. The product of vectors does two things for us. The dot product, is easy to calculate. Okay, I can easily calculate the dot product. And that dot product is used for a couple of things that we're going to talk about momentarily. One of the things it is used for is to help us determine how much of an angle lies between two vectors. So, as I said, there is a cross product as well, but cross products tend to be used when we start dealing with vectors in 3 dimensions compared to 2 dimensions. So, but as I said, the calculation of the dot product is the first formula. Basically, I take the first component of each, multiply them, take the second component of each, multiply them, and then add those two together. The second one is saying, okay, the dot product is also defined, and this should just be this would be another multiplication symbol altogether. An asterisk or something. Which means I take the magnitude of u times the magnitude of v times the cosine of theta. Now, that means if I knew the magnitudes of those two and knew the angle between them, I could figure out the cross product. But usually what we do is we typically are able to calculate the dot product value. We should be able to find the magnitude of the two vectors. And as far as the theta, or the angle between them, I actually reconstruct this formula to find that direction. Perpendicular or orthogonal vectors. Algebra 2 lines are perpendicular if their slopes are opposite reciprocals of each other. That's how we define them in algebra, and how we would say that the two lines are perpendicular. Vector notation. Now some books say perpendicular vectors, others will say orthogonal. They are the same thing. Two vectors are perpendicular if their dot product is 0. The thing about vectors is that I don't necessarily have to have them actually connect with each other to be orthogonal. Okay? They just have to go in directions that would allow them, should they be continued, would be perpendicular to each other. It gets kind of hokey with that. So basically the paths of the vectors are perpendicular, or to be orthogonal, whereas lines have to actually intersect each other to be orthogonal. Parallel vectors. Vector notation, two vectors are parallel if I take the ratios of the second component over the first component. I get the same thing, which kind of deals with what the slopes are. Depending on what textbook you're looking at, vectors, in the Axler textbook, vectors do not have to be heading in the same direction to be parallel. In some other textbooks and in other areas of math, they do have to be heading in the same direction to be parallel. So that's where it gets a little confusing at times, because sometimes, it was with one idea of understanding, you would say these two vectors are parallel, and there's other disciplines that say, no, they're not parallel because they're not heading in the same direction. For our purposes, they don't have to be heading in the same direction. So long as that ratio, b over a equals d over c, you're good.